Hi, everybody. So today I'm going to be using Matlab to optimize a portfolio. So let me go ahead and define some tickers. So these are going to be SPY, Apple, Microsoft, Nvidia, and JP Morgan. And let me go ahead and declare the time intervals. So that's going to be T0 is going to be equal to 2024 of January 1st, and T1 is going to be equal to 2024 of December 20th, which was yesterday. So I'm going to come over here and call this function fetch data, and it's going to take the argument of tickers T0 and T1 and then end that. So I'm going to come down here and do fetch data of tickers T0 and T1. So let me loop through the ticker. So for I equals 1 to length of tickers end and to display tickers of I. Okay, good. So we got that. So now what I'm going to do is create a variable called close and make it request uh, tickers of I, T0, and T1. And then what I'm going to do is once I have that, I'm going to declare an empty list up here called result, and I'm going to come here and create an empty list called temp. So what it's going to do is I'm going to loop through close. So for j equals 1 to the length of close end. So it'll be temp equals temp, comma, close of j dot adjusted close. And then over here, I'm going to do result equals result of temp. And now I'm going to display the data, but I'm going to add a pause timer for 2 seconds so I don't get rate limited. So pause 2. So now run it. And it didn't do anything. See. Unrecognized function data. Okay. Oh wait, it's not even data, it's result. So let me run it again. Oh, okay. So the data managed to load. That's good. So I'm gonna do return. No, I'm gonna do data equals result transposed. Okay, so I'm gonna come over here and call this X, and then I'm gonna do display X. So let me go ahead and clear this, and now I'm gonna run it. And we got it. We got our closed prices, so that's good. So now I'm going to calculate the rate of return. So it's going to be, so let me get rid of X. So it's going to be ROR equals X, no, ROR of X. And then what I'm going to do is display tickers of I. So let me go ahead and display ROR. So that's SPY, Apple, Microsoft, Nvidia, JP Morgan, and the rate of return. So okay, so now what I'm gonna do is generate a plot. So it'll be standard deviation equals STD of ROR, mu equals mean of ROR, and then it's going to be scatter um, as standard deviation mu. Um, I'm going to make the dots red. So let me close this off and then let me do hold on. So this is going to allow overlaps of the plot. So the next thing I need to do is this part actually. So it's going to be for I equals 1 to the length of tickers and then end. So it's going to be standard deviation of I. Instead of names here, I'm going to call it tickers of I. And these are all going to be black. So I'm going to do hold off down here, run it. Okay, so this is so these are the stocks. Maybe we could okay, Nvidia has really high volatility. What I'm gonna do is I'll take out Nvidia and I will add what's in so we got Apple, Microsoft, Spy. Or no, I'll keep Nvidia. I'll just add some more stocks to this, so it'll be like Amazon, Tesla. What's another good one? I'll do Walmart. Okay. So now that I've got those loaded, it's time to fit the curve. So in order to do that, okay, so I got my fetch. So I'm gonna do this. I'm gonna call this function fit curve, and it takes the argument of, or no, I'll call this EF curve, and this is gonna take the argument of x. Um, so yeah, I'll do it like this. So what I'm gonna do now is compute the covariance matrix of, so I'll call it covar equals cov of x, um, and then it'll be mu equals mean of x. Um, so then m0 equals the min of mu, m1 equals the max of mu, um, n equals 100. So dm equals m1 minus m0 divided by n minus 1. And then, so the covariance and the mean target rate are going to be inputted into the function. So I will come up here and call this function op equals optimizer, and it takes the arguments of covariance, mu, and rate. Um, yeah. So end. So the first thing I'm going to do is do covariance equals 2.0 times covariance, and then it's going to be yeah. So I'll just come here and do optimizer of covariance mu, and I'll just include a sample rate equal to like m0 plus 3 times dm. Okay. Let me go ahead and lower my stock count just for this, just so I can like optimize this portfolio. So I'll just add a pause timer of 1 in here. So I got covariance. So N is going to be the length of mu, and then it's going to be 1s equals 1 of n by 1. So then I will do covariance equals covariance covar mu, and then covariance equals covariance of 1s, display covariance. So now I need to call EF curve on this data. So it's going to be a EF curve of ROR, and then run it. And recognize variable 1. Oh, I think I had it the other way around. It's supposed to be 1s, 1, 1. Or dimensions of arrays are not consistent. Oh, right. Okay, so I have the two stocks and their covariance. Oh, no, no, no. Okay, yeah. Yeah, so this works. Okay, so now I'm gonna do mu equals mu of 0. Or rather, I think I could do mu of n plus 1 equals 0, mu of n plus 1 equals 0, and then do covariance equals covariance mu. So let's see how this looks. Okay, good. The covariance matrix is being built. So I could do 1 of n plus 1 equals 0, 1 of n plus 1 equals 0, and then do covariance equals covariance 1. Oh, right. Um, Transpose that. Okay, so now this is good to go. So now I need to compute b, which is going to equal zeros of n by 1, and then b n plus 1 equals rate, and b n plus 1 equals 1.0. So let me display b. Okay, so now it'll be weights, or rather OP equals the inverse of covariance multiplied by b. So now we have okay. So now we have that. Oh, it's telling us to try okay. Yeah, I'll do covariance b. So now I come over here, I will do w equals optimizer, and then display w. Oh, actually, okay. I have one more thing. So instead of OP, I'll do W equals that, and then WW equals zeros of just n by 1, and then for I equals 1 to n end. So it'll be WW of I equals W of I, because we don't want the Lagrange multiplier, so it's going to be OP equals WW. So now let me run it. Okay, so we got our portfolio weights. So now we could loop through the rates. So for I equals 1 to n, and I will declare a, let's see, x equals zeros of n by 1, y equals zeros of n by 1. So it'll be, let me go ahead and get rid of these. Okay, so inside here I will do, let's see, w equals, I called it optimizer of covariance mu and m0 plus I times dm, and then it's going to be risk is going to equal the weights transpose multiplied by the covariance matrix multiplied by weight. So I'm going to display risk just to make sure I did it right. Yep, I did it right. So it's actually going to be before I forget, this is going to be the square root to convert it into standard deviation form. So now return is going to equal weights transpose mu. And now let me display return just to make sure it worked. Okay, let me try it that way. Okay, I did not want, yeah, let's see. Okay, so I'm gonna display size of, wait, let me do f print f. So it's gonna be, oh no, just display, size of w, display size of mu, and break the loop. 2 by 1, 1 by 2. Okay, so it should actually be mu times w. Yeah, so this will be return equals mu times w. So now let me display return, and let me get rid of this break statement, run it. Okay, good. So, all right, so that's good. So now it'll be x of I equals risk and y of I equals return. So this is actually going to have two variables, so EFX, EFY, and then I'll come down here and do EFX equals X, EFY equals Y. So this should return two variables, and then I'm going to come down here and do, well, actually, I could do it right up here. So now I want to do it after the annotations, so it'll be, I'll call this UX, UY equals EF curve. And then I will do plot UX, UY, um, Yeah, let's see if I can have a blue plot. So now I'm gonna hit run. And there we have it. So here's the efficient frontier curve for these two stocks. So let's see if this scales up to the other ones. So I'm gonna press play on that. And we have it. These are okay. Let me get rid of Walmart. I'm gonna run this one more time. Let's get that curve in there. So run it. To think this is MATLAB, like getting market data in MATLAB is really cool. Um, okay, yeah. So yeah, this is our efficient frontier curve. These are our stocks risk and average daily return. Um, so we saw how like the data was fetched from financial modeling prep. The request was sent. We calculated the rate of return. We fetched all the data. I coded the optimization function, imported these seven stocks, plotted their standard deviations with their means and so on. So yeah, I thank you all for watching my video. I'm gonna keep coming out with more and more good content, so stay tuned and peace out.